Hi everyone. Let's continue on UV spectroscopy, and today we know the instrument. So the principle UV radiation region extend from 10 nanometer to 400 nanometer, and the visible radiation region from 100 nanometer to 800 nanometers. This is the visible radiation and this is the UV radiation. So visible and UV radiation have different interaction with the sample, but can be in the same in the same instrument called UV visible spectroscopy. This radiation have maybe extended from 10 to 8 nanometer. You can use in one instruments. The common solvent used for preparation solvent to be analyzed is either ethyl alcohol or hexane, and later we know why we use ethyl alcohol or hexane as a solvent. The sample absorbs a portion of incident radiation. The remainder is transmitted to the detector, where it's changed into an electrical signal and display. So we put the sample in the instruments and we introduce UV visible radiation. Some of this radiation absorbed by the sample and other is transmitted to the detector. The difference between the incident and transmitted to the detector, we can know how many photon of electromagnetic radiation absorbed by the sample, and we can know the quantity of the sample of the reagent in the sample. From it we can and from the data we can use to quantify the sample and calculate the content percent of the material in the sample. Analytical application of absorption of radiation by meter can be either qualitative or quantitative. Can be used this interaction between the electromagnetic radiation and the sample, which in this UV in this instrument is absorption, can be used for qualitative and quantitative. And display of absorption versus wavelengths is called absorption spectrum of the molecular species and serve as fingerprint for identification the sample. When we display absorption versus wavelengths, this is absorption and this is wavelengths. We can use this spectrum, it's called absorption spectrum, to like fingerprint for identification of the sample, and can be used for quantitative the sample. This is UV visible spectrometer. This is a light source, and this is a mirror prism, and this is the sample, and this is a detector. Light source is a beam of light generated by lamp passing through prism to obtain specific wavelengths, and this is the source can produce different range of energy, and we use mirror or prism to select specific wavelengths, which in this UV visible range from 10 nanometer to 800 nanometer to be passed through the sample. Some of them absorbed by the sample. Light passes through the sample, dissolve in a solvent, then the detector measure the energy absorbed by the sample. This detector can be used to measure the energy absorbed by the sample, so from this data can use to calculate the quantity of the sample. There is two types of UV spectroscopy. One is called one beam UV visible, and the second is called two beam and single beam. This is a one beam source light, filter or monochromator or prism or whatever. This is the sample. This is the detector. Firstly, عندنا reference sample and cell sample. When we measure the reference sample, this is the standard materials. We know concentration of it. Firstly, we have to prepare standard solution of concentration similar to theoretical concentration of the sample. If the theoretical of concentration of the sample 5 molari, say, we have to prepare standard solution 5 molari. So when we measure the absorption of the reference standard materials 5 molari, we calculate 5 molari concentration of the sample of the standard, absorption say 0.2. So when we replace the reference cell by the sample cell with the sample cell is theoretically 5, but the actual concentration is unknown. So the X concentration of the sample produce how many absorption, say 0.23. So by multiply, we can know the concentration of the sample. And without here is a double beam, without put the reference sample, take the reference sample, put the sample. Here is two cells, one for reference sample and one for reference sample, and this for sample materials. This is a reference standard and this is sample on all subtraction from immediately from each other to produce the concentration of the sample.